Hello, in this video, we are going to learn about the Bayesian probability and belief network. Bayesian probability. There are two views of probability. Objective, based on physical probability. Subjective, which estimates the probability from past experiences, degree of belief. It's a form of subjective probability. Beliefs are updated with new evidence. It's used to predict the likelihood of future events. Example in cricket selection. Probability of a player being selected depends on the number of matches played, player's role, whether it's a batsman or all-rounder, etc. It helps model relationships and infer outcomes. The significance includes it is crucial in decision making under uncertainty, extension of logic for reasoning with uncertain statements. And hypotheses, propositions. These are the statements that are either true or false. If the question is the batsman out? The answer could be either true or false. Random variable, it's an item with an unknown status. It can take a Boolean value, a discrete, or it could be continuous also. Hypothesis, it's a proposed explanation for an observed event, usually in a if-then format. Example of a hypothesis is if a prisoner learns some skilled work while in prison, then he is less likely to commit crime after release. This is an example for the testing hypothesis. One more example is a good teacher can increase the student's satisfaction. It's like this. If A occurs, then B, where A is antecedent, which is the hypothesis, and B is the consequent. Of probability. The first one is the classical probability. We call it as priori theory. In the sense, for an event A, the probability of occurrence of A is given as follows. Probability is equal to number of favorable outcomes resulting in event A divided by the total number of possible outcomes. Number two, joint probability. It is the probability of all events occurring together. It will be written as probability of A, B. Marginal probability. It's an unconditional probability of an event A, irrespective of the occurrence of event B. It is calculated by adding the joint probabilities of A over all occurrences of event B. This gives the marginal probability of event A. It's also called as an unconditional probability, which corresponds to belief without any observed data or before the availability of the evidence. Continuity, it is the probability of some event A given occurrence of some other event B. It is expressed as probability of A given B, and mathematically it is written like this. Probability of A given B equal to probability of A comma B divided by probability of B. Probability, it updates the belief after evidence. The equation for the conditional probability for probability of A given B is P of A given B equal to P of A comma B divided by P of B. We need to calculate P of A comma B from this equation to get the product rule. So P of A comma B is equal to P of A given B into P of B. This is the product rule. The equation for the conditional probability for P of B given A will be P of B given A equal to P of A comma B divided by P of A. From this equation, when we compute P of A comma B, which is equal to P of B given A into P of A. Now, we have to substitute this equation in the product rule. This particular equation in the product rule. So, which gives the Bayes theorem. So, P of and B equal to P of B given A into P of A divided by P of B. which is the Bayes theorem. So this is used to infer the probability of hypothesis under observed data or evidence. This is termed as Bayesian inference. Bayesian networks. It represents relationships using directed acyclic graphs. The nodes are the random variables. The edges represent the dependencies between the variables. The dependent node of a node is the child node, and the one on which it is dependent is the parent node. The parent node is called the cause and the child node is called the effect. It is used in the probabilistic reasoning and decision making. Now let us see an example for the Bayesian networks. This is an example for the Bayesian network, and this gives a lot of information. Say this is Coach Milland, and this represents whether Shyam is selected and Ram is selected. Here, the coach is Milland, the probability is 0.9. There is coach is not Milland, probability is 0.1. Coach is Milland and Shyam is selected 0.6. No coach and Shyam is selected 0.5. Shyam is not selected and there is coach is 0.4. Shyam is not selected and there is no coach is 0.5. Likewise here. Ram is selected and coach is there 0.8. Ram is selected and there is no coach, it's 0.1. Ram is not selected and there is coach is 0.2. Ram is not selected and there is no coach is 0.9. Probability that coach is equal to Milland is 0.9. Probability that Ram is selected and the coach is there, it's 0.8. Probability that Ram is selected and there is no coach is 0.1. You could see when we are summing up the column, it gives a value, say 1. Now, let us compute the probability that Ram is selected. So, probability that Ram is selected, how to calculate it is probability that Ram is selected given a coach and probability for the coach plus probability that the Ram is selected given no coach and probability that there is no coach. So substituting the values. So the probability that Ram is selected and there is a coach is 0.8. 0.8. Then probability that the coach is there is 0.9. So we take this from here. Then probability Ram is selected, there is no coach is 0.1. So we take it from here, we substitute. Probability that there is no coach, we fetch it from this table, it's 0.1. So when we calculate, the probability is going to be 0.73. Then moving on, we are computing the probability of the coach given Ram is selected. So probability of the coach given Ram is selected from the Bayes theorem. This is probability that Ram is selected and the coach 0.8. Probability that the coach is there, it's 0.9. And the probability that the Ram is selected, so we take it from here, 0.73. So the value is 0.98. So maximum probability, say 0.9. So what is the inference that we do make from here is, so since this is 0.98, we suggest that Milland is the coach and Milland's coaching is strongly influencing some recommendations. We can reasonably infer that Shyam also has a high chance of being selected based on this probabilistic reasoning. So this is getting propagated. In this session, we have learnt about Bayesian probability and belief network. Thank you.